Here I'm going to explain to you the equation of a tangent to a function or a curve. I'll use the word function or a curve because every function can be put on a graph, which I call as a curve. Now, the tangent to a curve. What is a tangent to a curve? The formal definition is beyond the scope of our curriculum. The best way to understand the tangent to a curve is to consider the slope of the tangent line as a derivative of the function. The tangent line to a curve at a point A is a straight line that passes through A and has a gradient equal to the derivative of the function at A. I have seen many learners you have the wrong notion that the tangent implies it touches the curve only at a point, which is wrong. Yes, in the case of the circles and parabolas, tangent line only touches the curve only at a point. However, the tangent can intersect at more than one point of the tangent line can intersect at more than one point of the graph, but it will be a tangent only at one point. And we will see how we'll visualize this tangent to a curve. Let us use a graph and see what is mean by tangent to a graph. I have a graph here, as you can see, there's a graph here, some graph, and I have a point on the graph. I have a point on the graph. So there is any point on the graph. Now let us understand this graph. This graph here from the left, you can see this is coming down. Therefore, this is decreasing graph, and it reaches a point here which we call the stationary point or a turning point, and then it goes up, and then again it reaches a point which is a maximum here or a stationary point or a turning point, and then it comes down. So now we call this point here as a turning point, we call them as a stationary point, and we also call them as a maximum point. So now I will draw a graph. There is a tool here that will allow me to draw a graph tangent to a graph here. Now, this straight line is a tangent to the curve at the point A. And I can move the point anywhere on the graph so that it moves. Let us see here the graph as I drag the point A on the graph, the tangent to the curve changes, as you can see. Now each point on the graph will have a derivative, and each point on the graph has a tangent. The gradient of the tangent is the derivative of the function at that point. You can see the gradient here is negative of the tangent. The gradient of the tangent is negative. The derivative is also negative. For decreasing functions, the gradient is negative. And for increasing from this turning point to this turning point, the function is increasing. The derivative will be positive, and the gradient of the tangent is also positive. As you can see the graph here, the gradient of the tangent is also positive. Now, what I want to emphasize is that this graph may also have a point here. You can see here there is there's a point here A, right? But this graph will also intersect this straight line, also intersects the graph at another point which is called C here. But this tangent that we see here is only at A, is not a tangent at B, at C. You can see here. This tangent may intersect the graph at 2 points, this straight line, but is a tangent only at A, it is not a tangent at C. So the actual definition of a tangent is not intersecting at one point. It is actually the derivative. The derivative of the graph at A will be the gradient of the tangent at A. Don't assume that AC is don't think the gradient of as AC. Of course, AC will have a gradient, right? But the tangent at C is something different. Is this straight line that you see here is only tangent at A. I can draw another tangent at C. Let me try to draw that another tangent at C. So there will be another tangent. This graph will give me another tangent at C. So these are different tangents. This tangent will also again intersect some other point. So what I want to emphasize is that the tangent, definition of the tangent is something very critical, but we are not learning the definition of the tangent in the case of calculus as we hear. But just understand that the derivative at the point is a gradient of the tangent. Let's here look at the question. Determine the gradient of f of x at some point. So we have this function f of x is equal to negative x squared plus 3x minus 6. So you have to find the gradient of f of x. That means what I'll do, I'll find f prime of x is equal to negative 2x. I apply the rules of differentiation here. I hope you are now familiar with the rules of differentiation. Negative x square now will become 2. This 2 here will come to the coefficient and reduce the power by 1. And 3x, apply the rules of differentiation. The power of x here is 1. 3 times 1 is 3. And reduce the power of x by 1. That is 1 minus 1 is 0, which is 1. So that's how I get the gradient. And that's how I get the derivative. Sorry. Now what I do, I have to find at x is equal to 3. That is f prime of 3. I substitute 3 in the derivative. Right? I substitute 3 in the derivative to find the gradient. Right? I am finding the gradient. That is my derivative. So it is minus 2 times 3 plus 3 will give me negative 3. Therefore, gradient here is, so the gradient at x is equal to 3 is negative 3. Right? Is negative 3. Now, next question is to determine the equation of the tangent to the curve. So here, the equation of a tangent. So equation of a tangent is given by y is equal to mx plus c. Now my m is given by negative 3. So this gradient is negative 3 here. The derivative at the point 3 is negative 3. Therefore, my gradient of the tangent is negative 3. So I got m. Now I need a point to find c. So I have this equation of y is equal to negative 3x plus c. So I need to find a point. So how I find a point? So I find a point of the intersection of the tangent and gradient. It's a common point. So what I'll do, I'll substitute now into the original function. This 3 I substitute in the original function to find the y coordinate, to find the common point. So it is negative 3 squared plus 3 times 3 plus 6, sorry, minus 6. So that will give me, sorry, this is minus 6. And it will give me how much? It will again give me negative 6. So the common point of the curve and the tangent is 3 and negative 6. I substitute this point here. So I put 3 negative 6 here. So that will give me negative 6 is equal to negative 3 times 3 plus c. And I get z is equal to 3. I solve for c. Therefore, I get z is equal to 3. Therefore, my final answer here is, y is equal to negative 3x plus 3. So this is my final answer. That's how I find the equation of a tangent. So the key point here is, first I find the derivative. And at the point, I find the derivative at the point. The derivative at that point will be the gradient of the tangent. Then I find the common point and then substitute that point to find the equation of the tangent. The question is find the coordinates of a point of the curve where a tangent to the curve is parallel to the line y is equal to 3x plus. So here what we must understand here is there is some graph here and there is a line, there is a tangent, some point here, and there's a point here, and there's a tangent, there is a tangent here. We do not know the point, we do not know the exact equation of this tangent, but we know this line is parallel to some other line, and the equation of that line is given. Okay, so now what we are going to do, first we find the derivative f prime of x. F prime of x is 2x minus 3. I hope that is clear. I derive this x squared minus 3x plus 7. That's my first derivative. What I know here is that the gradient of the paraline is 3. Therefore, the gradient of the tangent line will also be 3. I apply that we have learned in analytical geometry. Parallel lines have equal gradients. Therefore, the gradient, we do not know what point. We do not know the point of intersection of this point. We do not know what point it is. It is some a and some point here, x and y. So we have to find the point here. So that gradient is 3. Therefore, at common point of intersection, 2x minus 3 is equal to 3. This 3 here, the gradient 3. That's what I written here. Therefore, I solve for x. Therefore, that is equal to 6 and x is equal to c. So I got the x coordinate of the common point, which is equal to 3. Now I find the y coordinate. I substitute in the original function. That is the y. To find the y, what I do, I find f of 3 is equal to 3 squared minus 3 times 3 plus 7. I solve for it. I get 7. So therefore, the common point here is the common point of intersection, or the common point here is 3 and 7. That's how we get this answer.